AP Singh sir, your audio is not on.
Oh, sorry.
Okay, sir. Okay.
No, it's on. Sorry. Actually, there is some problem with my audio in the laptop. So I'm speaking from my mobile phone audio. I'm using the mic of the mobile phone and screen from the main laptop.
Okay, sir. No
It
issue,
is
sir. Now your audio is fully audible.
okay. So so I'll say again, welcome to this lecture. Good evening to all the participants. This is Amrit Singh from Jalandhar, NIT Jalandhar, and will be presenting this lecture on self-compacting concrete, development of self-compacting concrete. Uh, I'll just give a slide on infrastructure development in India. Okay. Major part of the infrastructure development is in the form of highways, bridges, airports, rail network, multi-story buildings. We have seen a lot of activity in this sector in the last couple of decades, and these days it's picking up more and more with the more than 100 trillions of dollars promised to be put in this field. India has one of the largest road networks in world of more than 3.3 billion kilometers. This is an uh, older figure. It will be more now. Expressways and highways constitute just 2% of the above. But there's a lot of improvement has taken place in the last 30-40 years, where there used to be a two-way road. Now it is a 10-way road with two service lanes and 6 main lanes. India has one of the largest rail network in the world, more than 63,000 kilometers, and still more work is to be done. Traffic volume is set to will be trebling in the coming years up to beyond 2020. Now we need to bridge infrastructure gaps to sustain economic growth. And in infrastructure development, concrete is the predominant construction material, the other being steel. But still, steel is lesser used, and we have more concrete, more reinforced concrete elements buildings. A major share of the infrastructure development is in the form of concrete structures. Construction industry in India constitutes around 40 to 50% of the capital expenditure in India on projects in various sectors. The total size of Indian construction industry is estimated to be 50,000 million USD and is growing at an annual rate of 7 to 8%, which is expected to pick up. India has the largest construction industry in Asia after China, and still more progress is expected after this pandemic, and some major activity is likely to be shifted to India. For that, more infrastructure projects will be coming up. Over 40,000 construction companies are registered with construction industry associations across the country. Construction industry has mainly small contractors, companies, and a few large corporates. Concrete is the world's most versatile, durable, and reliable construction material. It is the most widely used construction material because structural steel construction is relatively expansive
Sir, your voice is again not audible.
Sir, the speaker is not audible.
Yes, yes, sir just left the meeting. They again joined. Please wait some time.
This is a, 95-kilometer long concrete road. It passes through plain as well as hilly terrain and many tunnels. It's one of the busiest roads in India and has a capacity of carrying up to 1 lakh passenger car units daily. And presently, it is carrying around 50,000 passenger car units daily. Another one is the Exhibition Center in National Academy of Construction, Hyderabad. Now, when we are talking of self-compacted concrete, I'll just try to define the compaction of concrete and what is self-compacted concrete and why do we need self-compacted concrete. The first slide is on compaction of concrete. Compaction of concrete can be defined as process of elimination of entrapped air from freshly placed concrete. This results in significant increase in strength and durability, two of the most important aspects which are considered for concrete. If the concrete is not well compacted, it leads to a porous concrete and segregated concrete and porous concrete, and a lot of air is entrapped in it. And it has been researched, established by research, that a mere 10% entrapped air results in a 50% reduction in the strength of concrete as compared to that of a fully compacted concrete. Compaction, in addition to increasing the strength, also leads to better even distribution of pores, which will lead to reduced permeability. These are the few diagrams. They're self-explanatory and show that if the compaction is not proper, you will see like this concrete segregated, all coarse aggregates at one place and a lot of exposure to reinforcement.
Sir, again, voice is not audible. Please check your connection, sir.
And hmm?
Sir, better stop and rejoin again, sir.
There was a problem in the net. It's getting obstructed again and again. I'm sorry for that, but I rejoin it as soon as it's possible, and I'm going ahead with this. Uh, yes.
Okay, sir, you can proceed.
Okay. Okay. I'm sorry the net is getting obstructed again and I have to rejoin every time. But I'll be doing it, and I regret that inconvenience. But it's like that. Now, the necessity of self-compacting concrete, we need, because in columns, joints, or in places uh, where the high strength is required and compaction is not possible. Otherwise, compaction is not possible, and vibration leads excessive vibration also leads to some problems. So we go in for a concrete which compacts itself under its own weight. Now, self-compacting concrete is a new specialized concrete, and it compacts under its own weight, fills all the corners of the formwork, even in congested reinforcement areas like in shear walls and in joints of beam columns.
Again, sir, voice is not audible. Sir, your voice is not audible to the audience.
1983, and concern for durability of concrete structures, very poor compacted and partially vibrated. Then Professor H. Okama of Tokyo University, he developed the basic concept. And in 1988, prototype for field experiments and implementation. And in 1989, open experiment. Then 1991, joint research work construction company. And then various performances, various developments took place in years 1993, 1997, 2001, and so on and so forth, still carrying on in this field. Then benefits and limitations of using self-compacted concrete. Benefits are many: time saving and faster speed of construction, labor saving, safety and less mass produced, ease of placing through dense reinforcements, higher in-place quality and aesthetics. There are a couple of limitations or disadvantages or constraints which we can call, and these are uh, project constraints. Like it can be a problem in it can be a problem in structures which are sloping. For example, in bridge decks, if the bridge decks are sloping at more than 2%, then as the SCC is meant to be highly fluid, projects where concrete is required to immediately support its own weight may not benefit from its benefits. Like in bridges, if the slope is more than 2%, it will have to be supported from flowing. It will not be able to support under its own weight, and it will just flow away. So there something will have to be done. And similarly in structures like in sport stadia or in lecture halls or in cinemas where we have got rising seats, there also this problem of flowability of SCC creates problems. And we have got some organizational constraints which concern the concrete producer and the contractor. And the lack of skilled labor also is one constraint. Then proportioning of material, ordinary concrete versus self-compacting concrete. In ordinary concrete, we have got cement, sand, gravel, water, and plasticizer. In SCC, in addition to these in addition to these cement, sand, gravel, and water, we also need chemical admixtures like fly ash, rust ash, or silica gel, and we need plasticizers and thickeners, and that is the difference between proportioning of material for ordinary concrete and self-compacting concrete. In self-compacted compacted concrete, the requirements are high volume of paste, high volume of fines lesser than 80 micro um, high doses of super plasticizer, use of viscosity modifying agents, lesser of coarse concrete, and we need admixtures. The mechanism of achieving self-compaction: reduction of water to binder ratio, limitation of coarse aggregate and its maximum size, addition of material and admixture, use of super plasticizer and VMA, the addition of mineral admixture and use of super plasticizer, that leads to high deformability of mortar and concrete. And the first three, that is reduction of water to binder ratio and limitation of reduction in quantity of coarse aggregates and limiting its maximum size and additional of
Sir, again you are not audible. देखना दोनों ऑडियो ऑन है वीडियो. Hello, sir. AP Singh sir ji, you are not audible.
requirements for self-compacting concrete mixes. A concrete mix can only be classified as self-compacting concrete.
Sir, again you are not audible. Sir, please check your connection.
Which we use for filling ability. Uh, I'm speaking from another mobile. First is slum flow by Abraham Stone, T50 T50 centimeter slum flow, V funnel method, and odometer method. These are the four methods which are used for testing the filling ability of the self-compacted concrete. Uh, slump by slump flow by Abraham's cone and T 50 centimeter. This is the uh, this is a cone which is filled with concrete, and we lift it up, and we have a circle of 500 dia, and it has to spread over this circle, and the time taken to spread over this circle of 500 dia is known as T50 centimeter or T500 time, and it should pass that limits prescribed to be classified as a self-compacting concrete. This is a V funnel test, and again this concrete is filled in this funnel, and the gates are open, and the time taken to empty that vessel is measured. This is the third test, that's orimeter test, and as the figure shows, it's self-explanatory. It's filled from the top, and gate is open. It is kept there for, okay. Then we have got passing ability testing methods. There are four methods: J ring, L box, U box, and fill box test. This is the L box test, and we fill the concrete in the box, and it flows, and then we determine measure the heights H1 and H2. Measure the heights H1 and H2, and their ratio of height H2 to H1 should be less than 1. This is the J ring test. Again, they are all filling flowability test, and we fill the concrete and remove the cone, and then we see the spread, measure the time, and see the distance to which they can go. This is the U box, and this is the U box test, and the next is the fill box test. Then we have got the third stability testing methods. Which tests the whether the mix is segregating or bleeding is there. We have got column segregation test. We have got V funnel at 5 minutes test. We have got GTM screen stability test, and we have got visual stability index. This is the column segregation test. V funnel test, we have already seen earlier. There the concrete is put in the funnel and kept there for 5 minutes, and then we let it flow and see whether the aggregates have segregated or not. Now, influence of material characteristics and proportioning of on fresh properties. Number one is powder, filling ability, powder, that is the binding material, how it affects the filling ability, passing ability, and stability. Powder binding material, it gives packing density, particle shape, and reactivity of powder combination used can impact the water or admixture demand. Minimal to no impact on passing ability, and fineness of the powder will impact bleeding characterization and viscosity. Viscosity level will affect aggregate settlement. Then we have what second constituent, that is the aggregate. Optimum packing density and more rounded particles will increase the filling ability. More angular particle shape will reduce the ability of concrete particles to rearrange their relative position while flowing through a restricted space, whereas smaller particle will flow through the spaces more easily. Smaller particles will have lower tendency to settle and segregate. Higher fine content will reduce segregation and bleeding. High range water reducer increases the flowability of passing paste fraction of the concrete mix. In properly designed SCC mix, the higher fidelity paste will enhance all the three properties of the mix. Within a reasonable water powder range, an increase in powder content will increase the paste volume and paste viscosity, enhancing the filling ability, passing ability, and stability of an SCC mixture. Too great an increase in powder without an increase in water can lead to mixtures with viscosities that are too high, resulting in reduced filling and passing abilities. Too high an aggregate volume relative to the paste volume will decrease filling ability. Too high a concentration of larger particle sizes will cause blocking and reduce passing ability. The concentration is governed by the particle size distribution and mixture proportions together. Higher fine aggregate contents will reduce bleeding and aggregate settlement. Then high range water reducers, the increased water increases the paste volume and the filling ability as long as no segregation is occurring. In some instances, increase in water can increase the passing ability by increasing the paste volume and improving the filling ability. Too high a level of water can increase bleed and instability. This just shows a flow diagram Cement added, mineral additions, fine aggregate, coarse aggregate, dry mixing for 5 seconds. Then we add water, mixing for 2 minutes, followed by a pause of 1 minute for fall set. Then we add super plasticizer, again mixing for 2 minutes, measurement of slump flow, then remixing, addition of VMA, then remixing, then we perform all the tests which we have just now discussed: slump flow, V funnel, U box, L box, fill box test, etc., and other stability tests. Then self-compacting. If it qualifies all these, then we say it's a self-compacting. Yes. If it is failing in one of even in one of these tests, will cause remixing and then adjustments and then repeating the procedure all over again. These are the limits prescribed by different codes for those test values. Slump flow by Abraham Cohn. Minimum unit is mm, minimum 650, maximum 800. T50 centimeter slump flow measured in seconds, minimum 2 seconds, maximum 5. J ring, again mm, minimum 0, maximum 10. If it exceeds 10, means it has to be repeated. V funnel, again seconds, minimum 6, maximum 12. V funnel at 5 minutes, 0 and 3. L box, H2 by H1, 0.8 minimum and 1 maximum, more than 1, again repetition. U box, H2 minus H1 is 0 to 30. GTM screen, 0 to 15. Odometer, 0 to 5 seconds. And visibility index is normally 0, 1, 2, 3. This graph shows the market in billions of US dollars in year 2016 in the different parts of the world: Latin America, North America, Europe, Asia Pacific, Middle East, and Africa. Uh, and the lot of development is occurring in Middle East and Africa and Asia Pacific, so the consumption here is more, and it is increasing at a rate of around 6%. Then we have got some we have got special self-compacting concretes like high strength self-compacting concrete and lightweight for special applications, lightweight self-compacting concrete, heavyweight self-compacting concrete. Steel fiber reinforced concrete is also becoming very popular, and now steel fiber reinforced self-compacting concrete is also gaining popularity. We have rubberized, we have our recycled aggregate self-compacting concrete, nano SCC nanoparticles, pre-placed aggregates with mortar, ultra high performance self-compacting concrete, rock-filled concrete self-compacting concrete, silicon SC slurry insulated fiber concrete, high performance fibers, underwater self-compacted concrete, self-leveling concrete, and self-compacting mortars. These are some of the major constructions which have taken place in India using self-compacting concrete. And we'll come to now the conclusions. It can be concluded that SCC is an established technology offering many technical, economic advantages for a range of applications, but may not be feasible if these benefits are not fully required. A sustainable, eco-friendly solution with the potential to ensure long-term mm, quality, a high-quality end product which requires careful design and full understanding of risks, targeted testing, and good collaboration between all particles within construction. The improved construction practice and performance, combined with the health and safety benefits, make SCC a very attractive solution for both precast members and civil engineering construction. Based on these facts, it can be concluded that SCC has a bright future. Thank you. In the end, I'll like to offer my regrets because there was a lot of disturbance in initially in internet, and it had to be it went off quite a few times. So I'm sorry for that, but
Okay, thank you, sir. Participants, have you any question? Anyone from the participants? Have you any question? Thank you, sir. Before the end of the session, I would like to thank to you, sir, for giving us time from your busy schedule and enlightening your knowledge with us. Thank you so much, sir.
thank you very much. Thank you very much.
Thank you, sir.
बड़ी मुश्किल से किया था क्लास में क्या 6 बजे
Why not?
क्लास में